Friends, welcome back. In this tutorial we will study about Huffman codes. Huffman code is a technique for designing binary character code. It means we have to represent the characters by binary strings. Huffman codes are prefix codes. Now, what is the meaning of prefix codes? It means the one code word can never be a prefix of another code word. Suppose there is a character A and its binary code is 010, and suppose there is another character C and its binary code is 01001. So here we can see that this code word is the prefix of this code word, so it is not a prefix code, right? But Huffman codes are prefix codes. Here no code word is the prefix of another code word, right? So in this case, what happens in Huffman coding, the characters which are having high frequency, they are assigned the code of short length, and the characters whose frequency is less, they are assigned the code of larger length, right? Now suppose these binary characters are given to us A, B, C, D, E and F along with their frequencies. Frequency of character A is 45, frequency of character F is 5, frequency of character B is 13. Now we have to generate the binary codes for these characters by using Huffman coding technique, right? So to generate binary codes for these characters by using Huffman coding technique, we need to construct a tree. So first of all, what I will do, for every character I will construct a node, and the weight of that node will be the same as the frequency of that character. Now see, this is the node for character A. Its weight is 45 because the frequency of character A is 45. This is the node for character E. Its weight is 9 because the frequency of character E is 9. Now I have to construct the tree. So that tree will be constructed step by step, and at each step I will take two nodes whose weight is minimum among all available nodes, and I will merge them into a single node, and the weight of that node, right, the weight of that single node will be the sum of the weight of those two nodes which I have merged. So these nodes are available to me, right? So in first step I will find the nodes whose weight is minimum. The minimum weighted nodes are E and F, and I will merge them into a single node like this. And the weight of that new node, right, which is formed by merging these two nodes, is the sum of these two nodes, right? So sum of the weight of these two nodes is 14. So here the weight of this node is 14, right? These two nodes have been merged into a single node whose weight is the sum of these two nodes. Now among the available nodes, again I will find the two minimum weighted nodes. So these are two minimum weighted nodes. Their weight is minimum among all available nodes. So I will merge them into a single node, and weight of that node is the sum of the weight of these two nodes. So here the weight of this node is 13, weight of this node is 12. So when I merge them into a single node, the weight of that single node will be 13 plus 12, that is 25, right? So these two nodes have been merged. Now I have these four available nodes. So again I have to find the two nodes whose weight is minimum among available nodes. Only these two nodes are having minimum nodes among available nodes. Its weight is 16, its weight is 14. So again I will merge these two nodes into a single node, right? So these two nodes have been merged into a single node, and weight of that node is the sum of these two nodes. So now I have 3 nodes. So in these 3 available nodes, I have to find the nodes, 2 nodes whose weight is minimum. So weight of this node and this node is minimum, right? So I will merge them into a single node. Right, now I have only 2 nodes, this node A and this node, so I will merge them. So I will merge them into a single node. That sum of weight of these 2 nodes is 100. So weight of that single node is 100, right? So this is node A. So now a tree is formed. So I have to generate codes for character A, B, C, D, E and F. So what I will do, in this tree, all the characters are the leaf nodes, right? So I will start from root node, right? And whenever I move to left child, then I will label the edge by 0, and whenever I move to the right child, I will label the edge by 1, right? So see this node, from here when I move to left child, I will label the edge by 0. When I move to right child, I will label the edge by 1. And here also when I move to left child, I will label the edge by 0. When I move to right child, I will label the edge by 1. Here also when I move to left child, I will label the edge by 0. When I move to right child, I will label the edge by 1, right? Here also from this node, when I move to left child, I will label the edge by 0. When I move to right child, I will label the edge by 1, right? So after labeling all the edges, right, what I need to do, I have to find the codes for characters. Suppose I have to find the code for character B. So how I will find the code for characters? I will start from root node, and whatever is the path from root to that leaf, right? In that path, whatever is the label of edges, I will write, right? That will be the code for that character. So for this leaf B, starting from root, this is the path, right? In this path, edges are labeled by 1, 0, 0. So the code for character B is 1, 0, 0. Now see this D. What is the code for character D? You start from root and follow the path to leaf D. In this path, edges are labeled by 1, 1, 1. So character for D is 1, 1, 1. Similarly, for E, this is the path from root to leaf E. This path. So in this path, edges are labeled by 1, 1, 0, 0. So the binary code for character E is 1, 1, 0, 0, right? Similarly for character A, from root to leaf A, the path, this is the only path, and here the edge is labeled by 0. So the code for character A is 0, right? Similarly, see the code for character F. Now see the path from root to leaf F. Here the edges are labeled by 1, 1, 0, 1, right? Similarly, we can find the code for character C also. The code for character C is 1, 0, 1, right? So this is the way for finding Huffman codes for characters.